So we had some outstanding research presentations this morning. Glad to be a part of those. Today at right now, we're going to have Jim Albert is going to put on a workshop in R using baseball data. Jim is the author or co-author of Analyzing Baseball Data with R. He is a retired distinguished university professor at Bowling Green State University, and has written a couple of books in addition to the R baseball book, both on baseball stats and Bayesian statistics in general. So a little bit about how the setup works for these webinar rooms. In your chat panel, you can send stuff to us, and you can also use the Q&A. If you have any questions during the presentations, go ahead and type them into the Q&A. If you go down right next to the box for the chat, there's a Q&A box, and myself and Dr. Draper will be manning those and kind of trying to help out and manage the questions as they come in. So, Jim, are you with us here?
Yeah, I'm here. I just opened my video. Okay, here I am.
I think you might be muted.
He's good. I can hear him.
Okay, yeah, I'm here. I'm going to share my RStudio screen. Let me try that.
Jim, we're not getting the audio here.
No? Okay.
I can hear him just fine.
Okay, I'm talking now. You hear anything now?
I'm sorry, it's mine. It was my fault on my end. All right, thanks.
Okay, now what you should see now is you should see a RStudio screen. Can you see that? That's probably the most important thing at this point, is to see the RStudio screen. So I am currently in RStudio, and if you look at the right, I'm going to be working with what are called R Markdown files. And these two, there'll be two of these. One, basically, this will be two parts. The first part will be working with Laman data, and the second part will be using some StatCast data. And there are two files. One is called Laman.rmd, one is called StatCast.rmd. You can find both of those files in my GitHub folder. So there's a link address you can put into a browser, and you should be able to find those files. So one thing you can do, I'm going to basically work through these. Oh, by the way, I appreciate the opportunity of having the opportunity to present. I've been doing this stuff for a while. I was fortunate. I got to know Max Marchi, who is an Italian statistician who currently works for the Indians, and he had this book idea, and I was happy to have the opportunity to collaborate with him. And I also got to work with Ben Balmer, who had some experience working with the Mets. And so but anyway, I like the opportunity to present. So if you want to go, actually what you can do, if you're interested, is you can open up a new markdown file. And then then if you go to that website, you can literally just copy and paste that whole contents into a untitled worksheet, and actually you can work through this as like I'm doing. So anyway, so I'm going to work through it. So we're going to look at the Laman package. Is nice because it's a pretty interesting package, and it has season to season data for many things, for people, for players, for hitters, pitchers, managers, etc. And so let me give you some preliminaries. I'm going to be working in a markdown file, which is convenient because it allows you to combine text and R code. And as I said, all the R code is available here. And I definitely welcome, I mean, this is not the ideal setup. The ideal setup would be a little more in a lab or a place where you have your laptops, and we could do a little more, help you with your work on your laptops. So we don't have that capability now, but we'll do the best we can. And but you can ask questions in the chat window, and I will try to finish up by about the first session, about 15 minutes, and then we'll be there'll be a few minutes for questions. Okay, so so I'll be working with data frames that are located in the Lawman package. And for this first session, I'll be using 3 different packages. The Lawman package contains the data, and the dplyr package is useful for manipulating data, which we'll illustrate. And ggplot2 is a really nice package for graphing data. So what you have to do if you don't have these packages yet, you first have to install them into R, and then you load them every time you'll start R, you load them by means of the library function. Okay, so I'm assuming you already have some basic familiarity with R. So this is not new information for you. Okay, so what I'll be talking about, essentially all the data we will be using are all called data frames. And a data frame is essentially just a rectangular array of data. And the observations correspond to rows and the columns correspond to variables. Okay. And we'll be doing manipulations on these data frames. And I will be using different verbs, which is from the dplyr language. And then I'll be using this, I'll be passing along the data frame from one operation to the next. And there's this convenient piping operation, which I'll be illustrating, which allows you to do this pass along the data frame. Okay, now the verbs I'll be illustrating here, and here are the listing of 6 different verbs. Sometimes actually often you want to choose specific rows of the data frame. Using the filter function to do that. Sometimes you're only interested in certain variables, and you will use a select function to do that. Sometimes we'll be illustrating computing new variables, and the mutate function is useful for computing new variables. We'll be doing a top 10 list, and so I would like to arrange the data frame by 1 or more variables, and you can use the arrange function for that. And a very common operation is where you want to divide the data frame into groups by some variable, and the group by will allow me to do this division of the data into subgroups. And then once I divide into subgroups, I want to compute a summary, one or more summaries for each group. And the summarize function will be useful for that. So these are the 6 verbs I'll be illustrating. Okay, so we need a story to motivate our data analysis. And so we're going to focus on home run rate. Okay, and I'm going to define home run rate as the fraction of home runs hit on balls in play. Okay, and a simple way of computing the balls in play is to take the at-bats, the official at-bats, and subtract strikeouts. And that's called BIP, the balls in play. And we'll look at of all the balls in play, what fraction of those are home runs. HR corresponds to the home run count. And specifically, we're going to ask, okay, let's look at the last 60 years of baseball. The Lawman package only goes through last season, 2019. So we'll consider 60 years of baseball, and we want to find the top 10 home run rates. We're talking about season home run rates. And we're only going to consider players that had at least 400 at-bats. Okay, so the question is, and you might think that the top home run rates might be in the current seasons because there's so many home runs being hit currently in baseball, but we'll see that actually that's not true. So we'll see that there's somebody else who has a higher home run rate. Okay, so the plan here will be now the batting data frame is the Lawman data frame, which contains season batting statistics for every single player in Major League Baseball. It's quite a large data frame. And we're going to only consider seasons 1960 or later. And for each player for each season, we want to find the sum of the at-bats, the total strikeouts, and the home runs. once I have that information, I can compute the home run rate, which will be using the mutate function. And I want to store the results of my work in a new data frame called S for summary. Okay, that's a plan. So what I'll be doing is, so I have the code here, and I'm just going to run through the code. And I think I needed to first load the packages. Let me do that up here. So in the Markdown document, I just can hit that little arrow, and that will execute. So those are now loaded in the dplyr, ggplot2, and Lamin packages. And let's see. Okay, so let me explain what this does. I start off with the batting data frame, and I use the filter function to say, well, the year ID variable is the season variable. I want that season variable to at least 1960. And then I pass that data frame, and I want to look at every single, see, sometimes players play for more than one team in a single season. So I want to basically collapse over that. That's called stint. And I want to, over for each player for each season, I want to compute the total number of bats, strikeouts, and home runs. Okay, so I did it very fast. I just click that thing, and this does that operation. So it does exactly what I explained up there. And make sure that this is reasonable. I'm going to look at a few rows of this data frame, and we'll just show you the first few rows of that data frame. And there, now these aren't, I don't know who those players are. These are the player ID, which is some code for the player. This is the season, and at-bats, strikeouts, and home runs. Now this player probably is not going to have a great home run rate because his home runs are equal to 0, but we don't really care about the players who just play part-time. We're interested in players who have at least 400 at-bats. So what I'll do next is I'm going to take that data frame I just computed, and I want to look at the players who have at least 400 at-bats. So I use the filter function again. And then I want to compute this home run rate, which is defined to be HR divided by at-bats minus strikeouts. And I call it S400 because we're only looking at the players with 400 at-bats. It might be useful to show you some of those values. Okay, so here are some players. By the way, this actually is Hank Aaron. I recognize the player ID. And so Hank Aaron, 1960, he had 590 at-bats. His in-play home run rate was about 7.5%. Anyway, now I want to pick out the top players, the players who have the highest home run rates. And so what I want to do is, and I want to display the top 10. So what this is going to do is I'm going to take that data frame, and I'm going to arrange it. I want to arrange it from largest to smallest. And so it says arrange descending rate. And then I only want to pick out the top 10. And so this will be a subset of my original summary data frame. And let me display it. Okay, now this is a little hard to read because I have the player abbreviations and the year ID, and here are the top players, top player seasons. Now, this is not a great display because after all, I would prefer to have the player names rather than the abbreviations, the IDs. And also these rates are a little hard to read because they're not, there's so many decimal points. So what I want to do is, and actually I don't care about strikeouts. All I really care about is the home run rates. So what I want to do is I want to add the player names to this display. And then I only want to display the name, the season, the home runs, and the rate. And also I want to round the rate variable to 3 decimal places. Okay. So now how do I add the player names? Well, the player names are not in the batting data frame, but they're in a different data frame called people. And the people data frame will contain the player IDs and also give the first and last names of these players. So now this is actually a new verb, and this is a way of merging two data frames. And this says that I want to look at actually the master. I'm looking at the master data frame, which contains all the information of the players. I want to select, all I care about is I want to select the player ID, first name, last name, and those variables. I want to merge that information with the top 10 data frame. And in order to merge, I need a matching variable. And so I'm going to match these two data frames by the player ID. Okay, and that's called inner join. Will do that merging for me. And then I want to pass that along. I want to, again, make sure that these home run rates are decreasing. And I basically create my new data frame, which I'm calling top 10 again. Okay, so this looks better. And now I have a little more information. I have the first and last names. But remember, I don't really care about, by the way, it looks like I'm missing there's the rate. I got to clean this up a little more. Okay. And so I'm going to take that top 10 data frame I just created. I want to clean up the rate variable. I want to round that rate variable to 3 decimal places. And so I'll use the R function round, which allows me to round data. And all I want to select, only variables I really want to display are the first name, the last name, and the home run rate. Okay, and then I want to display that result. Okay, so looking good. So this is actually a nice display. We see that the highest season home run rate in baseball recent history was Mark McGwire. I remember actually where I was standing in our house when he hit when he broke Roger Maris's record in 1998. His rate of home runs in play was almost as 20%. And that's followed by Barry Bonds in 2001. That was the year he hit 73. But notice that McGwire was also the third and the fourth best in 1999, 1996. And then interesting enough, now we're jumping to 2017 and we see people like Joey Gallo and Aaron Judge. Jim Thome recently inducted in the Hall of Fame. Again, McGwire, Sammy Sosa, and JD Martinez. Okay. Now, now I'm interested a little bit in seeing what seasons are represented in this top 10 list. And so one quick way of understanding that the seasons is to graph the results. So what I want to do is I want to create a graph where I graph the year on the x-axis and like a scatter plot where I put the rate on the y-axis. Okay, so this will be a nice illustration of using the ggplot2 package for graphing. And so what this says here is I'm going to graph this. The first thing you do is you indicate the data frame you'll be working with, which is top 10. You indicate AES basically tells you what roles different variables play. Now I want to do a scatter plot. So I need X, so year will be the X variable, rate will be the Y variable. And this indicates that I'm going to plot points. And I do this and I see a nice display. So interesting enough, these top home run rates, a lot of them were around the year 2000, late 90s. And then basically there was a gap of time where we didn't have high home run rates. And now suddenly in 2017, you get some high values. So that's an interesting pattern. Now this graph could be improved because maybe you would like to know what players are represented by these points, because each point corresponds to a player for a certain season. So one way I can improve this graph is to, instead of plotting points, I can plot labels for the different players. And so the only thing I want to change here is I'm going to indicate that for my label variable will be the last name. And I'm going to use a different geometric object to plot. I'm not going to plot a point anymore. I'm going to plot a label. So I do that, I get this display. Okay, Jimmy told me he's a little hiding here, but now we see that McGwire is dominating the best home run rates in those early seasons. And we also see that Gallo, Judge, and Martinez are here in the later seasons. Okay, so this is interesting. Okay, now, actually, here I learned about these. So what we learned from this brief exploration is that some of the top home run rates were done in the so-called steroids era in baseball around the year 2000. And that raises the question, well, was that really a time when the overall home run rate was highest? So maybe, I mean, maybe we're not in the the great time of home run hitting. Maybe it really happened here. So maybe it'd be interesting now to look at the overall home run rate of players. Okay. And so what we're going to do is we're going to look at all players, and we want to look at the pattern of overall home run rates. Okay. And I guess I meant to say 60 seasons, right? Sorry. Okay. So now I'm going to use a different, by the way, if you want to find interesting data sets, all you would have to do is go to packages, and you would go to Lawman, and there's a listing of all the different data sets that are available in the Lawman package. And what you notice is that there's a lot of information. There's information about awards given, batting stats, fielding stats, who's in the Hall of Fame, the home run Hall of Fame voting data is here, information about parks, and a lot of information is here. Now, I'm going to be focusing on, instead of looking at the player by player data, I'm going to look at the team data. And this gives us the information about the batting information for each, and also defensive information for each team every single season. Okay, so here I'll be starting off with a different data frame, which is teams. And again, I want to focus on the years that are after 1960. Now for each season, which is the year ID variable, I want to compute the total count of home runs, the total at-bats, and total strikeouts. And then I want to compute the overall home run rate. Okay. And so by doing this, I'm going to put this in a new data frame called S3. So let me show you what this data frame looks like. So here are every single season, total home runs, total at-bats, strikeouts, and this is the home run rate. Okay, now I could look at that table, but I want a quick way of understanding if there's any pattern or any change across here is to construct a graph. So I want to graph this information. And so what I'll do again is a ggplot. Now my data frame is S3. And I want to plot the year variable on the x-axis and the home run rate on the y-axis. My plotting about my geometric object will be the point. And in order to see the pattern, I'm going to add a smoothing curve. And this is a traditional, let's call it a Loess smooth of a scatter plot. Okay, and it does this, and well, here's the pattern. Oh, this is very interesting. Okay, so here, remember I said that, so what we see is 1960, this is like Roger Maris, Mickey Mantle. The overall home run rate was pretty small. It got worse, actually, it actually had a low value in the 70s. I'm a Phillies fan, so I think in terms of the Phillies, 1980, the Phillies won the first World Series. And then suddenly things went up a little bit. Suddenly, this is the year 2000, the steroids era, home runs were relatively high. This is when we had Mark McGwire and Barry Bonds. Things started to die off, but suddenly, like during this, I call the StatCast era, the recent seasons, suddenly home run hitting has been going crazy. And so currently, at least last year, the home run rate was over 5%, which was the highest it's been in baseball history. So So although some of the great player accomplishments are more around year 2000, overall, the home run rate has been skyrocketing. Okay, so that's a quick analysis. Maybe actually at this point, are there any questions about what I've done? Maybe before I'm going to do something different now, but maybe now is a good time to answer any questions.
Jim, we had a question about it'd be line 81, the last command there in that chunk, dot groups equals drop.
Oh, yeah, this is, okay, all that does is it basically, this is a new version of dplyr. If you don't do this, then it's going to there's a group information that's included, and sometimes you want to do more analysis that use that grouping. I don't plan to use any more of that grouping information. So that, to me, this is a little bit of a nuisance. This is the newest version of dplyr, and if you don't do this, it's going to give you a little message. And I get irritated by that message, so I don't. It says something like it didn't say anything. Okay. Well, anyway, this will be. It's not that important. Yeah. Anything else?
Patrick asks if you can program the same information and use ggplot2 in the Python language.
I don't have a lot of experience with Python. Partly because I've not been, I think Python is a very similar language to R. The reason why I use R is as a statistician, there's so much more statistical packages available. So for doing my own research or for doing a lot of things, I mean, if there was a reason for me to, Python is fine. I think if you are familiar with Python, moving to R is not a big deal. Actually, in RStudio, you can actually blend in Python work with R work, which is one of the things. So it's probably, if you want to be a baseball analyst, you probably need to should be comfortable with both Python and R. So.
Thanks.
Okay, are we good?
Yep.
Okay. So let's look at it something a little different. Since we are this Ohio State University, we are both, I'm from another Ohio University. Let's look at Ohio colleges. Sorry. Okay, so let's look at this one little thing about Ohio colleges. So there's in the Lama database, there's a data frame called schools. But what I'm going to do here is I'm going to take that data frame, and I'm interested in all the schools. This basically, I'm interested in learning about the Major League Baseball players who've played at Ohio colleges. So the first thing I want to do is I want to get a collection of all the schools in Ohio that's in this school database. And so this will be just a vector. If I can just show you what's like. So these are all the different schools. These are abbreviations for all the schools represented. There are over 40 of these. And I'm interested in which colleges had the most seasons containing future Major League Baseball players. I know Bowling Green, for example, has had some famous players like Brand Jackson went to Bowling Green, and Hershiser went to Bowling Green. And so I'm interested in which colleges had the most seasons. So basically, I'm interested in not necessarily the most players, but the most player seasons. And the data which contains information about player seasons is the data frame called college playing. So I want to restrict my search to schools that are in this list of Ohio schools. And I want to basically count the number of player seasons for each Ohio schools. So I want to group the data by the school ID, and for each player count the number of player seasons. And I'm interested in the top schools. So I'm going to arrange this in decreasing by n. And not surprisingly, Ohio State appears to be on top, followed by Miami, OU, Kent State, Bowling Green, and Cincinnati. Okay. Now these are player seasons. So for example, if a player played 3 seasons for Ohio State, that'd be represented by 3 observations. Okay, so now let's look a little further. Among all the Ohio players, who had the most career hits in the Major League Baseball? Okay, not clear who that'd be. So what I want to do is I'm going to, again, look at that college players playing data frame. Again, I want to focus on the schools that are in my vector of Ohio schools. Now what this does, I want to poll, which means I want to select the variable, which is the player ID. Now here I'm actually taking that out out of a data frame and creating a vector of player IDs. And remember I said that a player could be represented more than once if they play more than 1 season. So I want to consider the unique values. And then, so this will be my list of Ohio players. And let me show you what it looks like. Okay, so there's my list, and it's a little hard to read because these are all the abbreviations. We can pick up the names from the master data thing. Okay, these are actually, there are quite a few. It looks like there are over 200 Ohio players. So for each of these players, I want to compute the number of career hits. Okay, so they go back to our batting data frame. We want to filter. So we only want to consider players that are in this vector of Ohio. This function in is very useful. I would just say the players that are in this list of players, or this vector of players. For each player, I want to group the data by player. That's like each little group. And for each group, I want to compute the sum of hits. And then I want to arrange the data frame in descending order by hits and show you the top 5. And let me show you what this looks like. Okay, now obviously here's actually a problem I knew the answer because I'm a Phillies fan, and probably one of the greatest Phillies players was Mike Schmidt, and there he is on top of the list. But again, this might be hard to read because you don't know what these abbreviations correspond to. So what I want to do is I want to add first and last names to this list. So what I want to do is I want to take this data frame I created and I want to merge using the inner join function. So from the master data frame, I want to pick out the ID, first and last names. I want to merge that data frame with top hits where the matching variable is player ID. And now I also want to make sure that this is arranged in descending order. Okay, there we go. So we see that Mike Schmidt was at the top, over 2,000 hits, followed by Frank Howard. He played for the Washington team. Bill White was a great, he played with Phillies for briefly, but he was a great player for the Cardinals. Jimmy Wynn played for Houston, and Thurman Munson played for the Yankees. So these are the all played for Ohio schools. Now you could actually, might be interested in learning what schools these players came from. Mike Schmidt played for Ohio University. Not sure the rest. Okay, well, let's go on. Let's look at to see who was the best Ohio pitcher. And we're going to measure pitching performance by total wins. That's a crummy measure, but we'll use that as a measure. So again, now we have a different data frame, which is called pitching. And we want to filter, we only want to consider players that played in Ohio. So we want to filter where the player ID is in that list, that vector of Ohio players. And for each player, I want to find the total number of wins. And so basically it's the same kind of operation. I want to look at the top 5. I want to, I'll do that computation. And then I want to add the first and last names, just like I did before. And here we have that the top players are Orel Hershiser, who pitched for Bowling Green. He had 204 wins. I didn't realize before this exploration that Sandy Koufax pitched for Ohio College. I didn't realize that, and which is interesting. And then Tim Belcher, Charlie Leibrandt, and Terry Mulholland also played for the Phillies. And you might want to be interested in which Ohio schools these pitchers attended. So what I do is I look at the college players. All I want to look at these top 5, so these top wins. So I'm interested with the player ID is in the, now this is a way representing the top wins is my data frame. $ player ID picks out the player ID. And I want to group by player ID, but see, most of these players played for more than one season for college. So I just want to pick out the first school they played for, which is usually the same school for all the seasons. Okay. So when I do that, I find that these are the teams represented. So Hershiser played for Bowling Green. Koufax played University of Cincinnati. This one was Miami, Ohio, and Marietta, and Mount Vernon, Nazarene. So none of these pitchers pitched for Ohio State. Okay. Okay, so the opportunities for analysis using the Lawman package are pretty nice, are pretty good. So you can do quite a bit with this. Since we just had the World Series, here are some obvious questions you want to ask about the World Series. So for example, which teams have won the most World Series? Now we know the answer is the Yankees, but we might be interested in the other teams in the top list. For example, the Phillies only won twice in their history, which is pretty small. Certain teams have never won, like Seattle. But okay, so here there's a new data frame called Series Post. And this will give you data information about all the postseason, all the playoff games. And I only want to look at the situations where we're looking at the World Series, which is the round variable, and WS indicates World Series. We're only looking at the World Series teams, and we want to look at we want to group the data by the winner of that World Series. So for each possible winner of the World Series, we're going to count the number of times that team has been the winner. Okay. So summarize, n of parentheses is just like a counting variable. So basically, it'll pick up the number of rows where that team ID was each possible team. And again, we're interested in the top teams. So again, we will arrange by, again, we'll go decreasing order of n, and I'll show you the top rows. Okay, so it looks like, and these are the abbreviations for the team, and if you want to get more thorough description, you can. Okay, so okay, there is the Yankees are at top. This is in American League, followed by St. Louis. Cardinals have won the World Series 11 times, followed by the Red Sox. Actually, I'm not even sure what NY1 is. Is that the Mets? No. Have the Mets won 7 times? Anyway, the Reds have won 5 times, and then followed by the Dodgers. Actually, this is not updated, so actually the Dodgers have won 6 times now. So, okay. So, and you might be one, no, okay, the Yankees have won 27 times. What seasons did they win the World Series? And so here I take the same data frame. I break it down, the round is equal to World Series. And again, I pick out the times when the the winner was the Yankees, which is abbreviated by NWA, and we'll pull out the year season. So here are these seasons, and so you see that Yankees won the World Series quite a bit in the 30s and 40s, 50s, 60s. They were dominated, and then after 62, they had a gap, and now you see there was a run where they won the World Series 4 times. Looks like they beat and last time they won the World Series, they beat the Phillies, which was 2009. So they've been in a little drought since 2009. Okay, so I finished up this. I can do a lot of extra things here, but I think a good way of you to learn more about R is to explore more questions. Here are some, I just picked out some questions to explore. Here's the definition of a walk rate. So the walk rate, you look at the number of walks divided by the plate appearances, which is approximately equal to the at-bats plus the walks. So let's find the 10 players in the last 60 seasons with the highest walk rates. So you might want to see when those players played. And we also, one type of play we see in baseball is a triple. It's sort of a rare event nowadays. And so you might be interested in looking at triples, which I'm defining by the number of triples on balls in play. And so you might want to find that, I'm suggesting find the triple rate for all seasons and see how that's changed across season. Do we see a pattern? I suspect there'll be a pattern there. Both triples and stolen bases are considered speed plays because the players who get them typically are fast runners. So here's a simple question. Is there a relationship between the triple rate during a season against the number of stolen bases? I'm not sure in this case of the relationship or not. So anyway, these are the things that you can explore. Okay. So do you have any questions, or is it a good time to stop for questions?
Looks like we're good on questions. I think the mystery New York team was the Dodgers.
Oh, the Giants.
Oh, the Giants?
I'm not sure. Well, actually, it's easy to find.
Yeah.
Again, that's a good question. What team was that? So you would just go, let's see. So again, you want to find the relevant data. And so we're looking at series post, right? So we want to do the same kind of thing, right? So maybe, okay, so I guess you want to look at teams data set. So you go to teams data set, and then you want to filter where the team ID, is it team ID? Is equal to NA1, right? And let's look to see what the team's data set looks like. So we have the team ID. Do we have a name of the team? Actually, I don't see the name of the team here. Maybe it's probably in a different place. Let me go back. So maybe it's a team franchises table. So maybe go to team franchises. And we want to filter where the franchise ID is that. And let's look at, and let's select French name. It's important in R that it doesn't like it when you misspell things. Didn't pick anything up. I wonder. Okay, that's a good question. So something, obviously that didn't work, but it illustrates, that's interesting. Okay, anyway.
All right, I think that now would be a good time to take a little break and let people work on some of that stuff there, and then we'll come back in a little bit.
Yeah, let me give you a preview. So on the second half of this, I'm going to look at some StatCast data, focusing on 4 pitchers during the 2020 season, including a person who just won the Cy Young Award for the National League. So we'll look at his data. So.
All right, and that's on, I'll put a link in the chat to the, that's on your GitHub page as well.
Correct. It's called StatCast RMD.
All right, thanks. And I'll stick by the Q&A stuff during the break here too, and we can take a look at that.
Okay, great. Thanks.
All right, thanks. We'll start back up at about 11.
Just to throw that out there, it's the Giants. If you join, I think Jason is mentioning it as well. You can join the team ID to there's a franchise ID that you can join between the team data and the franchise's data, and it's the Giants.
Giants. Okay, great. Thanks. Thanks for clarification. Okay.
As we're getting ready to start the next session here, I put in the chat the link to the exact GitHub page with the markdown file for the next part, the StatCast data. Also, if you have questions during the presentation, it's easier for us to get to them if you put them in the Q&A thing rather than the chat. There were a couple that we missed until a little bit later. It's easier for us to have our discussions in the chat, and then the Q&A have the questions that we want to address to the panelists. So it's 11 o'clock. Jim, if you want to take back over here whenever you're ready.
Great. Okay. Do you see my screen?
Yep.
Oh, that's good. Okay. So last hour I was looking at Lawman data, which is a great source of data. We are currently living in a period of a new type of data called StatCast. And this is, we've had 5 or 6 years of this type of data. And it is, you can find it through Baseball Savant site, and you can scrape it by means of the Baseball R package, Bill Pettit. So anyway, so what I've done is I have StatCast data for the entire 2020 season. And that's a relatively large data set, and it's not real convenient to put online, but I could put a portion of that data set, make available. So I'm going to focus on 4 pitchers, notable starting pitchers during the 2020 season, and we'll look at their pitches. Okay, so what this database gives us is it provides a lot of information about every single pitch throughout a baseball game. So you've got indications of who is pitching, who is batting, speed and movement and location, and a lot of other things. What happened to the pitch? For example, was it a called strike, or was it swung at, or there was a swing and miss, or was there an in-play event or something? That's all recorded to us. So it's a very, very rich data set. And so we're going to focus on learning about pitchers. And again, we'll look at 4 starting pitchers. And specifically, so again, all the work I'm doing is in a markdown document called called statcast.rmd. And you can go to the GitHub site and you can pick this up, and you can actually, if you want to, you can put it into RStudio and start working with like I'm doing now. Okay, so so I have the Statcast database and I created a subset, which I'm making it publicly available. And again, this will allow us to look at things like pitch type, speed, break, location, and outcome. Okay, so we're going to focus on those variables. Okay, and there's the link for the GitHub things. And again, I think what Ryan said is you should put your questions in the Q&A window, and then we'll get back to those when we can. Okay, now for the purpose of this presentation, I'm going to use 4 packages. We won't be using the Lama data, so we won't be using that package. Again, we'll be using dplyr, which is useful for manipulation. readr will be useful for reading a data set from my GitHub site, ggplot2 for graphing. I'm going to introduce a new package called Janitor. And I like this because it allows you to do create some tables, which we'll be looking at some tables. And it basically works well within the tidyverse environment, with the dplyr environment. Okay, now we'll be plotting locations of pitches. And when you plot that, these locations of pitches, you typically would like to show the strike zone, the edges of strike zone. So I have a little bit of graphics, a little function, which will put that zone onto a graph. So I'm just going to read in a function called add zone, and I'm sourcing it from a website. So all that doesn't do anything. All it's going to do is read this packet, this thing called, if you look at your files, it's not files, look at your, well, anyway, this will be a function that'll be in my workspace. Okay, so, okay, here's the data that I've collected. It's called, I'm using the read._CSV function to read this from the web. And this is the address for that data file. So it's going to read in that data file. And let me show you a little bit about it. I'm going to find the dimensions of this. So there are basically, what I have here is every single pitch thrown by 4 pitchers. We'll see this, what pitchers they are in the 2020 season. So there are a total of 4,334 pitches. There are 93 variables collected for each pitch. So there's a lot of variables. And the Statcast data you scrape has 90 variables, and I added 3 new variables to make it easier to do this work here today. I'm going to add in a variable called pitcher, which is the last name of the pitcher. We'll be looking at the pitches where the batter took a swing. And so there's a new swing variable. Either if the swing variable is 1, he did swing at the pitch, 0, he didn't swing at the pitch. And for pitches that are swung at, we want to know, did the batter make some contact? And so there's a miss variable. 1 means that he missed the swung pitch, and 0 means he didn't. Okay, so we'll be using those 3 variables in addition to the usual Statcast variables. Okay, so what variables did I include? You have to realize I live in Ohio, but I'm a Phillies fan, so I had to consider a Phillies pitcher. So it looks like we have, our 4 pitchers are Trevor Bauer, recently got the National League Cy Young Award, pitched for the Reds. I don't think he's now a free agent. I doubt he'll be a Reds player next year, but we don't know. Garrett Cole for the Yankees, dominant. He had a big contract for the Yankees last year. And so we have 1,203 pitches from him. Clayton Kershaw, probably one of the most famous pitchers, future Hall of Famer. He won his first World Series this year. So we have pitches from him. And as I said, I'm a Phillies fan, so I got to bring in a Phillies pitcher. So we have Zach Wheeler, who pitched for the Phillies this year, had a pretty good season. And So again, what this table TABYL function will do is it'll give me the number. So there's a pitcher variable, and this is the count, and this is the number of fraction number of pitches for that pitcher. So this is not useful in this context, but okay. So we're going to focus on these four pitchers. Now we want to look at types of pitches, and that's sort of, I can spend a long time talking about pitch types. There's a relatively new book called Off-Speed Pitcher, Baseball Pitching and the Art of Deception by Terry McDermott. A nice description of different kinds of pitches, as each chapter is devoted to a different kind of pitch. So these are, and they have abbreviations in our database. The most popular pitch is the four-seam fastball, which is the one you throw the fastest. That's a straight fastball. Currently, pitchers throw fast four-seamers from like the low 80s to the 100 miles per hour. A two-seam fastball is like a four-seamer, but it's gripped a little bit differently, and it has more movement. It doesn't, usually not throwing quite as fast, but it has movement. There are two kinds of curveballs that are represented in the database. One is called CB curveball. One is called a knuckle curve. And this is your probably the most basic kind of breaking pitch. You put a lot of spin on the ball, and it breaks both horizontally. So if you're a right-handed pitcher, it goes from right to left, and it typically goes down. A slider is a different kind of breaking pitch that moves differently than a curveball, and most pitchers throw sliders. We have a cut fastball, which is similar. It's sort of it's between, in a sense, a slider and a fastball. Changeup is very popular. It's sort of like a fastball, and it looks like a fastball, but it is about 10 miles slower. And so when you think it's a fastball and it's a changeup, then you typically will swing too early and you'll miss the pitch. You have a sinker, which is sort of like a two-seam fastball. The break is down. And you also have a thing called a splitter. So these are all different types of pitches that are represented in our database. And so there's one variable which gives you the actual name of the pitch, and there's a different variable which gives you the code. So I'll be using both the code and the name. Okay, so given all those pitch types, what were the common kind of pitches? I'm just going to execute this. And okay, so of these pitches, looks like the most common pitch was the four-seam fastball. About 44% of all the pitches are four-seamers. Essentially most pitchers throw four-seamers. After the four-seamers, looks like the most popular pitch is a slider, 23%. And then it's a mix of changeups, curveballs, cutters, knuckle curves, and sinkers. Okay, so to be an effective pitcher, you need a four-seamer, but you also need a couple of contrasting pitches like a curveball and a slider. Okay, so we know there are all these different types of pitches. Now, let's say we want to know which pitcher threw which type of pitch. So here we're going to do a contingency table or a tabulated data. We're going to tabulate the data by the pitch name and also by the last name of the pitcher. Okay, this is very helpful. So for example, Trevor Bauer is a bit unusual because he throws literally 5 types of pitches. Bauer is quite an interesting player because he definitely works a lot in his pitching, and he's more scientific than other pitchers, and works a lot on his pitching. Cole is primarily a fastball, knuckle curve, and slider. Clayton Kershaw throws a four-seamer, a curveball, and a slider. And Zach Wheeler throws 5 pitches. So he's sort of more like Trevor Bauer. But you see, they all throw four-seamers, and they all throw sliders. Otherwise, they have different kinds of pitches. Okay, now when you think about pitching, usually you think about speed. And if you go to a baseball game, you would typically see the speed of a pitch. This is actually StatCast data that's being broadcast or being displayed on one of the displays in the stadium. So what I'm going to do here is I want to look at fastball speeds. I'm going to draw a graph. And so so what this says here is when a ggplot, I only want to consider pitches where the pitch type is FF, stands for four seamers. And I want to graph the release speed. This is the speed of the pitch, miles per hour, when the pitcher releases it. And now if you don't pick the color, then by default, our ggplot will give you the black bars, which I don't think is very pretty. So I want the color is the color of the borders. I want that to be white. I want the fill color to be blue. So, and if I do that, and I get this picture. Interesting shape. This is bimodal. It looks like a lot of the fastball speeds are in the middle 90s, and then there are another group of fastball speeds in the upper 90s. Okay. The reason why we have bimodal distribution is that these four pitchers throw their four seamers at different speeds. Okay. So really, I would like to break down or basically show this kind of graph for each pitcher. So the nice thing about ggplot2 is it allows you to do what is called facets or panels, where you have different graphical displays in different small little graphs, where the smaller graphs are organized by a categorical variable. So all I have to do is take that code, and all I want to change is I want to add one line to it. And this says that I want to basically have different histograms for each pitcher, and number of columns my display will be 1. Okay, so you get this display. So, okay, so clearly these pitchers differ. Now notice a couple of things that are interesting. First is that four-seam pitchers, even for a certain pitcher, they are variable. They don't throw all the same, there's some variation in their speeds, but clearly Cole and Wheeler throw faster than Bauer and Kershaw. In fact, Wheeler is very similar to Cole. Then comes Bauer, who throws in the mid-90s, and Kershaw he probably is dropped a little bit as he's gotten older. He doesn't throw quite as fast. He throws more in the lower 90s. Okay. Now, one way we can summarize this graph is to compute a mean speed for each pitcher. So what I want to do is I want to show you how to do that. So I'll be using the summarize function. So what this says is that, again, I want to only look at the rows that correspond to the four-seam fastball. And I want to group the data by pitchers. So basically I'm creating 4 groups. And so for each pitcher, I want to count how many fastballs, four-seam fastballs I threw. I'm going to compute the mean. Maybe if you want to, I can also compute the standard deviation of the release speed. Okay, and so if you execute that, it shows me that, yeah, indeed, Cole and actually Wheeler's got the highest average of 96.9, followed closely by Cole, and then Bauer, then Kershaw. Okay, and these standard deviations indicate that the standard deviation of these speeds is roughly 1 for each pitcher. There's some variation from pitch to pitch. Okay, now on baseball, it isn't necessarily about the speed is important, but you would like the pitches to display some movement. Okay, now movement is quantified by 2 variables. One is called, I think one is called pitch PFXX and PFXXZ. This corresponds to the horizontal movement, and this is the vertical movement of a pitch. So we're going to look at one pitcher, and I'm going to create a subset of my data. And I'm using the filter function to create the subset, and I'm going to store that in a new data frame called CK for Clayton Kershaw. And what I'm going to do is I'm going to plot, I want to graph the movements of all of his pitches. Now, if I just plotted the movements of all the pitches, that would be confusing because each type of pitch has a distinct movement. So what I'm going to do is I'm going to represent each pitch type by a different color. So basically, I'm plotting a scatter plot where I'm using the color as a new variable, which will correspond to the pitch type. Okay, so I create my new data frame, and then I create this new graph. Okay, now when you look at this graph, this is graph of movements. Okay, and actually we can ignore the. And by the way, when you look at this graph, the perspective is that you're watching this movement from the catcher's perspective. Okay. Also, realize that Kershaw is a left-handed pitcher. Okay. So his balls will tend to move to, as you're looking at the catcher, to the left, from right to left. So notice that all the horizontal movements of here are the curveballs, here are the sliders, and here are the four-seamers. All the movements tend to be negative. Okay. Now, for a right-handed pitcher, they would tend to go the other way. They tend to go from left to right to be positive. But notice that the main difference between these three pitches is how they move in the vertical direction. Okay. The fastball tends not to move. The slider tends to drop, and the curveball really drops. Okay. So, okay. So basically, you can be distinguished primarily from movement. Oh, by the way, you know, often when you go to a baseball game, you will, not only will you see the pitch speed, you also see the pitch type. How do they figure out the pitch type? Well, they basically, they're doing some sort of clustering algorithm where they're focusing on the speed and the movement variables. If you know the speed and the movement, usually you can classify the pitch. So again, you'll see here that the movement of the four-seamers is clearly different than the movement of the sliders and the movement of the curveballs. Okay. So the reason why, again, so the batter's got a tough job because not only does he have to worry about the speed of the pitch, he has to think about how these pitches will move. Okay.
Yeah. There are two questions in the Q&A that I think I want to make sure that I think that you'd be the one to answer them. One is asking, is there a gist or blog post to add on how to add the pitcher swing and miss to the data set?
No. Well, let me just back up a little bit.
And I apologize for not bringing it up earlier.
Yeah. Let me see. I'm going to open up let's see here. What I did, I don't have a data set, but basically there is I'm going to try to, let's see. Trying to get my console. Okay, there's a variable called, my data set is this. There's a variable called events. Okay. And notice that, let me see, that's not events. Let's try the $sign description. There's a description variable. And this tells you all the things that can happen with this is all the different things that can happen on a pitch. Okay. Now you notice that some of these are variables like swinging strike. Let me just look at the unique one, sorry. Okay, so these are all the different descriptions. And notice that some are, so for example, hit into play, score, foul, hit and play, no out, hit into play. Those are all swings, right? Swinging strike, swing. So basically what I did is I used a mutate function, which basically said that if the description is in one of these swing situations, then the swing is equal to 1. Otherwise 0. And then for this the miss variable, I said, well, if I have a swinging strike or a swinging strike blocked, then the miss would be equal to 1, otherwise 0. So basically, I define new variables based on this description variable. Okay. Okay, let me go back to my thing. Okay, so location. Now, this is like you know, when you want to sell a house, it's all about location. Likewise, when you throw pitches, it's often much about location. And the best pitchers are the ones who can locate their pitches effectively. So okay, so let's look at the pitch locations of pitches. So here now there are 2 new variables called plate X and plate Z, which will give you the horizontal and vertical location of the pitches as it crosses the zone. Okay, so what I want to do is I'm going to plot the locations of all Kershaw's pitches, where I'm going to use a different color for each pitch type. Okay. Okay, now this is not a great picture because it's hard to distinguish the different pitches because there's a lot of overlap. And the second problem is that I don't know what offhand where the zone is, the strike zone is, right? Again, this is the perspective here is from the catcher who is looking at these pitches. Okay, so what I want to do next is I'm going to add a zone. So remember we sourced in a new function, which is called add zone. And this is a simple function I wrote that will add a layer zone to this graph. And so it's the same graph, but now you see the strike zone. So you might be interested in the fact that a lot of these pitches are out of the strike zone. Okay, so and if you look a little more carefully, you notice that a lot of the purples are low. So really, when Kershaw throws a slider, he typically wants to throw it low in the zone. Okay. Okay, now it might be helpful if I divided this display into 4 small displays for each pitch type. So I'm doing the same graph, same code as up there. The only difference now is I'm adding a new, I want to do a facet for each pitch type. And I want this to be a 2x2 display. And so I get this picture. Okay, so this shows you the location of his changeups. He didn't throw many changeups. His curveball is, by the way, I wonder if these were really changeups or this was an error in actually classifying that pitch. But anyway, here is curveballs, 4-seamers, and sliders. Okay, what I see here is that Kershaw tend to throw his fastballs pretty much within the zone, right? And not that much that's low. You tend to go, if they tend to go a little high, possibly a lot of them in the zone. In contrast, the curveballs tend to be low in the zone. A lot of these curveballs are low. Likewise, the sliders tend to be low. Notice that they tend to be, since Kershaw is throwing from right to left, the sliders tend to go that direction. So, and so, for example, if you are a right-handed hitter would be on, a left-handed hitter would be on this side. For a left-handed hitter, the slider would be going away from you, which is probably an effective pitch. Okay, so not only does he throw different pitches, he throws these different pitches with different objectives. Okay, so he throws, I think, his fastball to try to get a strike, but he really throws a curveball and a slider out of the zone to induce a miss. So the next thing we want to look at is how effective he is in getting the batter to miss the pitch. Okay, so we're going to look at Kershaw's, let's focus on his curveballs, because I think he wants to get a swing and miss on a curveball. And so we want him to swing. So we want to consider the cases where the swing variable is equal to 1. And also I want to record on the swing if there's a miss, which is miss is equal to 1, or not, which would be a 0. So now these new variables I computed will be helpful to try to answer that question. Okay, so first we're going to graph the data. The only thing that's different here, we're going to focus on the curveball. So we only want to consider the pitches where the pitch type was CU as a curveball, and also focusing on only the pitches where the batter swung. Okay, I don't want to consider all of the curveballs, just the ones where he swung. And then I want to plot the location, plate X and plate Z, and I want to color the point by the miss variable. And I want to plot points, and I want to add the zone to the graph. Okay, not a lot of data here, but what this shows you, black is where the swinger didn't miss. I mean, batters like curveballs that are in the zone, but notice that as Kershaw throws low, the batters tend to miss, a lot of blues in that region. And that's generally true for pitchers, that a lot of the misses on curveballs, the batter is fooled, and the pitch often is in the dirt, for example. Often that's very striking in baseball when you see a batter swing at a curveball that's in dirt, but they were fooled and they swing. Okay, so let's be a little more quantitative here. So we see that there were a lot of misses on these curveballs that were swung at. What fraction of the curveballs that were swung at were missed? So now what we're going to do is we're going to filter on the balls that are curveballs. We're going to focus on the swings, and we're going to tabulate the miss variable. Okay, so it looks like he threw a total of 74 curveballs where they swung, and 24% of those curveballs were missed. Now, is that, when you say 24%, should that impress you? I don't know. Well, maybe we should compare our pitchers, right, to see if 24% is a high percentage. Well, it's actually a fraction, but they call it percent. Okay, so let's compare this miss percentage with the pitchers. So here, now there are two pitchers among our pitchers who threw curveballs, and they were Clayton Kershaw and Zach Wheeler. So they're the only two that threw curveballs. Remember, the other two pitchers, Bauer and Cole, threw a knuckle curve. So we'll look at knuckle curves in a second, but Kershaw and Wheeler threw curveballs. So we're going to again filter, where we're going to consider cases where a pitch was a curveball and was swung at, and we're going to tabulate the miss variable for each pitcher. And to make it easy to make a conclusion, we're going to compute row percentages, which you'll see in a second. Okay, so for the Kershaw, we already knew that 24% of the curveballs were missed at, but compare that to Wheeler. Wheeler actually was more effective in his curveball because he had 38% of his swung curveballs were missed. So in some sense, Wheeler was more effective than Kershaw. Now, those were the curveballs. A very similar kind of pitch is the knuckle curve, and that's thrown by Garrett Cole and Trevor Bauer. So here we're doing the same kind of display where we focus on the knuckle curve is abbreviated by KC, and they're taking a swing. And again, we're tabulating the miss, the pitcher and the miss. Okay, and if you want, that's the tabulated value. If we want to get percentages, we would add a what did I say, row? Yeah. Okay, so Cole was remarkably good. Notice that 46% of his swung curveballs were missed. Now, so Cole, you see why he's such a great pitcher is that not only does he have a great fastball, but he has a pretty good curveball, and he's a lot of the, which is often missed on a swing. Now, Bauer isn't quite as good, 33%, but it's still better than Kershaw. Okay, so in terms of, you want to measure the pitchers by their effectiveness on their curveball, maybe you would rank them, Cole be at the top, and then Bauer and Wheeler were similar, and then Wheeler was a little higher, I guess, and Kershaw was at the bottom. Now, I don't know, it'd be interesting to look at Kershaw to see how that's changed over the seasons, because obviously he's a great pitcher, and but maybe he's not been as effective on his curveball. Okay, now we talked about swing and miss, and it might be interesting to look at the movement of a certain kind of pitch. So we're going to look at the movement of his knuckle curve. So the question is, why do these batters miss on the swings? Well, maybe because of the movement. So here what I want to do is I want to look at for each pitcher, or here we'll just be comparing two pitchers that threw the knuckle curve. We're going to do a graph of the movement where I'm going to color the point by the pitcher. Okay, very interesting. Okay, these two pitchers, now this is movement, right? So from the catcher's perspective, the horizontal values are positive. These are both right-handed pitchers, and the movement is positive for both pitches, right? So they're moving from left to right. But notice that there's basically both pitches drop. They both go down. But notice that Bauer's movement is higher negative. It's like they're very, very different than Cole. So in terms of movement, Bauer tends to get more movement on his knuckle curve than Cole does, which is interesting. Okay. So maybe one way you can distinguish these pitchers, even one, is the kind of movement. And you might argue that that Bauer's movement is better in some sense because he wants the ball to drop, and he gets it to drop more than Cole. What about the location? So here we're going to look at the same pitch type, but now we're going to look at the location of the pitch, and we're going to create points, and we're going to color by not going to color, we're just going to use different graphs on the same scale. I'm going to add a strike zone to this. Okay, well, this is interesting. So again, remember how we saw that when Clayton Kershaw was throwing his slider, the slider tended to go from right to left low. Well, Bauer and Cole are both right-handed pitchers. Their knuckle curve tends to go the other direction, as you might suspect. Tends to go to lower right, which is probably pretty effective against a right-handed batter. And Cole especially seems effective in throwing the ball out of the strike zone. So maybe the reason why Cole's got a better miss percentage than Bauer is that he basically locates his curveball, in a place where batters can't really hit it. So it's interesting. So obviously, I think both Bauer and Cole have the same objective when they throw their knuckle curve, but maybe Cole is a little better in them. Again, the idea is you would like the player to swing and miss. Okay, another variable that's collected in the StatCast data set is the spin rate. And that variable is called release spin rate. And generally, the way you think about this is you want to put more spin on the ball. And you usually think that if you have more spin on the ball, that will induce larger movement. Okay. And let's first look at the difference in spin rates. So here I want to do what I'm going to do here is I want to go and focus on the knuckle curves. And we're going to, for each pitcher, we want to graph the spin rate. Now, normally I would do a point graph like this. But it's a little hard to see this because there are a lot of overlapping points. This is not the greatest display. So one way you can avoid the overlapping points is to put the jitter of the points. Okay, this graph is fascinating to me because this talks about their spin rate. Whatever Cole does, noticed that there are two things going on here. First, on the average, Bauer tends to put more spin on his knuckle curve than Cole, right? Because these points on average are higher than these points. But then in contrast, Cole tends to be very consistent on his spin. So there's very little variability in the spin, while Bauer has more variability. Now, I don't know, I mean, maybe it'd be interesting to talk to Trevor Bauer to understand a little more about this. Is Trevor Bauer trying to put different spins on his knuckle curve? Maybe they have different objectives. But the pattern of these movement of the spin rates for these two pitches is interesting. Okay, so generally the reason why you put spin on a ball is that you would like to induce more movement. So you might think there's a relationship between a pitcher's spin, amount of spin they have, and the movement. So let's look at, for example, look at Cole's knuckle curveball. And so here we're going to look at the pitch type is KC, knuckle curveball. We're going to focus on Cole. We're going to do a scatter plot of the release spin rate. And here is the vertical movement of the pitch. And we'll plot a points and see if there's a relationship. And okay, there's a negative relationship, which is sort of what you want. I mean, it tells you that when there's more spin on the ball, then the ball tends to drop more because the value of the vertical movement is more negative. So there's some relationship here, but it's not real strong. And I did the same thing, but I focused on the horizontal movement of the knuckle curve. Same graph, but here the only difference is that I'm using the X variable. And so what this tells you is that when the spin is higher, then there's more, it turns out the horizontal movement is also greater, which also indicates, so it's generally, there is a relationship between the spin rate and the movement. Okay. And so what's really fascinating now is that pitchers are doing a lot of things with baseballs. They're doing a lot more testing. Trevor Bauer will actually, during the off season, he will go into a laboratory and he'll basically work on his pitch and he'll collect data, trying to achieve certain objectives in terms of movement and speed. And so, and there's a book that came out where he's sort of the poster boy for analytics and pitching, and which is real interesting. Okay, let's see. So obviously, let's stop now for questions on this. So hopefully I've illustrated the idea that this is an extremely rich data set. I've been focusing on pitchers, but you can also focus on what batters do with pitchers too.
So if we've got some questions, if we could put them into the Q&A box. We've had a few while we were going that Dr. Draper and I were able to answer, but if anybody has any more questions. Also, we are going to have some more baseball later today in room 2 at 3 o'clock. We've got our baseball panel. And then I'm sure in our first panel at 1 o'clock in room 2 with Ohio State, we have 2 Ohio State. 2 of the guests there are baseball coaches at Ohio State that have been working with us. or that we not have been working with us, that we have been working with to do some analytics stuff. So do we have any more questions for Dr. Albert while we're here?
While we got a little time here, I just want to, I do contribute to, when we started our book, it's been almost first edition came out like 5 years ago. We started a blog which focuses on exploring baseball with R, and we've had contributions from different people, and I'm still keeping that active. I think, really the fun thing about this is that any student could be at a high school level or college level. It's very easy. I remember what it was like growing up, and I was doing simulation games and keeping track of stats on my typewriter, but nowadays we have all this free publicly available data, and we have an open source language like R available. So the opportunities for doing your own analyses is just, you literally have the world, and things will continue to get better. We'll get better, more data released, and so it's quite remarkable of the transformation that's happened in this area. So.
All right, I put the links for the book and for your blog in there. David Hyland commented that he uses your book in his class. I believe he's at Xavier, if I'm correct. We do have a question in the Q&A box from Lloyd. Wants to know how are you able to successfully upload all of this pitch movement and other related advanced tracking measurements into R? Did you use Baseball Savant and the filtered?
I could illustrate that. You want me to illustrate? I could actually show you how to do it. That might be nice to do. Okay, so for example, it's hard to get the screen here. The problem is that let me just change my window a little bit. There we go. There we go. Okay, so there's a package called Baseball R. And there's so you basically go, let's say, function called scrape, Statcast Savant. And they basically now, only suggestion is that you put 2 dates. I wouldn't collect too much data at once because there might be a limit to how much it can handle. But for example, what was the date of the last World Series game? That was October, I don't know. Randy, about
27th.
27th, okay. So I go 27th, so basically I'm collecting the data and I go. So what that is going to do is, so it's grabbing data. So, okay. Okay, so what I have here is I have a new data frame of 4,000. So you look up here, there's a new data frame called D. I used the wrong word here, but as basically, that's not it. What I call this, new data, right? New data. So during that last World Series game, there were 259 pitches. So we have data, we've got the Statcast data for the last World Series game. So for example, we can look at the, do a simple table of new data. Let's go the events. Okay, so that game, we had 27 strikeouts. Okay, that was, we're going to talk about how baseball has changed. Notice there are 2 home runs, 3 doubles. What's remarkable is how few balls are in play for that game. It's basically a pitching matchup, 1 double play. We could, if we want to do a simple graph, we could do, okay, we could say what kind of pitches were thrown that game. Pitch name. Okay. 95 four-seamers, 30 changeups. You know, this was similar to other games that I did a blog post where it was the teams of the World Series were displaying interesting patterns of pitching. They've deviated from the usual, like 44% of four-seamers. They were showing, both teams were throwing more off-speed pitches than typical during the World Series, but there were a lot of strikeouts. Okay, other questions? Yeah, by the way, I'm happy to, if you've got specific requests or you have any just questions about what to do, my email is albert@bgsu.edu. And I'm not as obviously being retired. I have more time to do fun stuff like this than maybe I did before. So I'm still somewhat active doing baseball things. And so I'm happy to chat or offer suggestions. I mean, for people that don't know R, I can be a bit daunting at first to get started, but I think they're making the language, example, the tidyverse is a way of this new language I've illustrated here. I think it's sort of a nice thing and making it a little easier to do our analysis. It's not as much as programming, it's more just learning a language for working with data.
Yeah, and there's a lot of online resources available for those that are very new. And the first couple of chapters of that book there, the Analyzing Baseball Data in R, kind of goes through some of the real basics to begin with there.
Yeah. Actually, interesting enough, the first edition is a little more base R. The second edition is a little more tidyverse, and that's the Ben Balmer influence is obvious in the second edition because he redid my code, make it more tidyverse compliant.
All right. Well, thank you very much for your time today. I'm really glad that you were able to make it, and we did record this, and everybody that's here, the Zoom thing will automatically send you a thing when their recording is available. So, and we will be recording things all day, and then eventually we're going to edit the recordings and put them together nice and neat, so we don't have so many of the breaks and the other things in them. But thanks again. This was great.
Thank you.
There is one more question in the Q&A that I think would be pertinent.
Sure.
All right. Oh, I see. Any common pitfalls for beginners in sports data analysis and how to improve?
I'm sorry, what kind of?
So the question was if you're aware of any common pitfalls for beginners in sports data analysis in general, and kind of some ways to improve.
Well, I think the biggest problem for a lot of people is getting the packages installed and understanding where data is. I mean, the concept of folders and things like that gets people very frustrated because they'll download data and they aren't quite sure where to get to it. One thing that RStudio is a nice interface. One thing that RStudio does is what's called a project, where basically it's a place where you work, like for example, I'm doing a certain analysis, I'll keep all my work in a certain folder, be able to navigate there and work within that. I personally think what's going to happen in the future is I think you'll see more cloud, like there's a cloud version of RStudio. And from a teacher's perspective, the nice thing about a cloud version is that you can have all the packages installed and all the data, and the students don't need to worry so much about these issues, like Windows versus Mac and Unix, all these small issues like that, which can be frustrating for the beginner.
Yes, it can. We had, I have an R class that I taught in the spring, and they kept re-imaging all of the computers in the lab. So then we had to re-download every package on every Tuesday, which was pretty frustrating.
Yeah, I can relate. I know exactly.
Yeah.